Hello students, so we are solving the problems on projection of lines, and the problem we are supposed to solve here is, is given here. A line AB 70 mm long which measures 50 mm and 60 mm in front and top view respectively. The point A is 15 mm above HP and 25 mm in front of VP, while the point B is in first quadrant. So we are supposed to draw the projections of line AB and find the inclination of this line with HP and VP. So in order to solve this problem, first I will select the line thickness to be 0.09 mm for showing the faint line. Then we'll start with drawing a XY line. We'll start with drawing the XY line here. So this will be my reference line. Now since we'll try to mark point A first. Point A is 15 mm above HP and 25 mm in front of VP. So anywhere on this XY line I will mark point A. So let's say the projector for point A will pass through here. So from this point I will draw a line which is 15 mm above, and I will draw another line which will take care of 25 mm in front. So it's a top view in first quadrant, so it will go below XY line. So these 2 points which I get, which are the projections of point A. Now upper one is the front view, so I will give it a dash notation, that is point A dash, and the bottom one is the top view, so I will give a regular notation, that is point A. I am just adjusting up the points a bit so that I can easily understand where the points are. Now further it is given that the top view and front view lengths of these two lines are given. So instead of considering them as front view or top view lengths, I will consider them as elevation and plan length. Now elevation length is nothing but the front view length which is drawn parallel to XY line. So I will draw this front view length over here at 50 mm, and same way the top view length, that is plan length, I will draw horizontally at 60 mm. Once I am done with this, uh, whenever I get a plan length in top view, I will get the actual length in front. I will get the actual true length in the front view. So I will project this plan length upwards, and from point A dash I will try to mark a locus, a circular locus of the radius 70 mm. This is nothing but what we do with by drawing a circuit, drawing an arc with a circular. So I will just trim the excess part. I will trim this excess part. So where the line is intersecting, here I get the true length, which is 70 mm. Now since I got the point, I can delete the arc. Again, same way I will project this elevation length downwards, and on this elevation length I will try to cut a circle of radius 70 mm. Why I'm taking radius as 70 mm? Because 70 mm is the true length which is given. So that length will ensure what I'm drawing here is the nothing but the radius of the circle. So this way I'm ensuring that actual true length is being used, and then I can delete the remaining part, and this way you can see the length is 70 mm in front top view, and in front view also it's 70 mm. So here I got the actual true length. Now as we know, let me first complete the naming. When we get the true length in front view, the point is A dash and B1 dash. That means the apparent front view of point B, and the respective projection is B1, that is apparent top view of point B. Second point, when we get true length in top view, we normally name it as B2, that is apparent length, apparent point B in top view. And again we have a second apparent point in front view which goes by the name B2 dash. Now to get the actual front view, I will draw a locus of point B which will pass through B1 dash, and on this B1 dash I will mark a arc which will be equivalent to the length of A dash to B2 dash, and it will be initiating from centered at A dash. And if I join this point of intersection along with point A dash, this is nothing but the actual front view, that is A dash B dash. I will just darken it so that it will be easier to understand. Now same way I can draw locus from point B2, which will be locus of B now, and again I will draw an arc which is a start and center end type arc. So I will start from B1, take A as the center and draw the arc, and by pressing Ctrl on keyboard I can change the direction of arc. Now here I got point of intersection. This point of intersection is nothing but point B, that is actual top view of the point B. I can join point A and B, and this is the actual top view, so I will darken it. And as we already know, checking condition, we can just ensure that points B dash and B are along one straight line, or one straight line which is perpendicular, one vertical line I will say. So this line is making angle 90 degree, so the solution which I have drawn is correct as all points and their projectors match. Now we have been asked, first we'll mark the given point and then we'll mark the things which were asked to us. So let me mark position of point A dash first. So A dash was 15 mm above HP and it was 25 mm in front of VP. I missed the point over there. It was 25 mm in front of VP. Along with that, we knew the lengths of A dash, B2 dash, or it is same as A dash to B dash. So I will mark the length along A dash B dash, that is 50 mm, which was the front view, and A to B, which was the length of the top view, 60 mm. Now we are supposed to find the angle made by line with HP and VP. So these are the angles made by true lengths, that means A dash B1 dash. So the angle made with HP is 31 degree and angle made with VP is 44 degree. We can also calculate the angle for apparent lengths. So those will be angle made by line A dash B dash, that is 46 degree, and angle made by line AB with horizontal, that is 55 degree. So with this we complete the problem. I hope it clears your doubt. Thank you.